In the preceding, the equation x squared plus 4x plus 3 equals 0 came up, and we solved it using the quadratic formula. We solved it by factoring. Those methods won't always work, but I want to solve this equation by the other method that we should have available by now, which is completing the square. So we want to solve this by completing the square. You should pause and attempt to work this out using the technique of completing the square. Okay, whether you did or not, and you might not have if you don't remember anything about that method, but at this point of the course, you should. First step, x squared plus 4x plus what? Is a perfect square. Okay, what would we add on here to get a perfect square? Well, this should be x plus a squared, which is x plus a times x plus a, which equals x squared plus 2ax plus a squared. So we want to find a value of a that matches this form. And in order to match this form, and let me back up, I assume you know how to square a binomial by writing it out as the binomial multiplied by itself and applying not that thing I don't like, but the distributive law, x times x plus a times x plus a, and you see how that gives you this. There's also a special formula. This is a special formula that x plus a quantity squared does equal this, but you're going to probably get that formula messed up if you don't know how to verify it. If you're in the middle of a test and you don't know how to verify that x plus a squared equals this, you're really not very safe using this formula. Okay, well, to match this to this, you notice that the x squared matches. The 2ax will match if you choose the right value of a. So the 2ax matches 4x if a takes what value. You should pause, think this out before I tell you. Now I'm going to tell you. That happens if a equals 2. Okay? I'm going to write in parentheses here how we could work that out. You shouldn't, with these numbers, have to revert to this reasoning, but you should be able to revert to this reasoning. It matches if 2a equals 4, because the thing in front of x here has to match the thing in front of x here. Otherwise, these two terms don't match. And of course, if 2a equals 4, the only way that happens is if a equals 2. So we know that x plus a squared now equals x plus 2 squared, which is x squared plus 2ax plus 4. And I wrote the 2a here. I should have written 4. Let me get something to repair that with. I like to make a mistake every once in a while, so you don't get the mistaken impression that you're witnessing perfection here. Okay, so that's going to be x squared plus 4x plus 4. Well, what was our original question? X squared plus 4x plus what is a perfect square? Well, now the what is 4. X squared plus 4x plus 4 is the perfect square. I had to abbreviate that to ERF and SQ That's what I'm saying, perfect square. Okay, where's that leave us? Well, we've got x squared plus 4x plus 3 equals 0. In order to make this into x squared plus 4x plus 4, what do we have to do? Well, to change x squared plus 4x plus 3 to x squared plus 4x plus 4, you think about it. What do we need to do to this expression to get this expression? I'm going to tell you now, but I hope you stop to think about it. Okay, we got x squared plus 4x plus 3 equals 0. And to get an equation with a perfect square on the left side, we change this to x squared plus, well, we want this to become x squared plus 4x plus 4, so we better add 1 to this expression, and now we'll have the perfect square. But of course, if we add 1 to one side of the equation, in order to not change the meaning of the equation, we've got to add 1 to the other side, and we have x squared plus 4x plus 4 equals 1. Okay, where does that lead us? Well, think about it. What could you do with this equation? Now, if you've given it some thought, good. If not, well, I hope you're not just observing this as a spectator. I hope you're taking notes, and I hope you're thinking, because if you aren't, not much is going to happen. Okay. X squared plus 4x plus 4 is what? Well, that's just x plus 2 quantity squared. That's an easy factor. And here now we have the equation x plus 2 quantity squared equals 1. Now this should be no surprise, because how did we get this equation in the first place? We got it by expanding x plus 2 squared equals 1 and subtracting 1 from both sides to get this. Okay, so we've kind of come full circle. The advantage to the completing the square method is that you can pretty much always do it, and it reduces an equation that would require factoring or the quadratic formula. And remember, you can't always factor, even though you can always apply the quadratic formula. It reduces the equation to an equation of this form, and this equation is cause for great joy because it's easy to solve. So we get x plus 2 equals 1. Obviously, again, if x plus 2 equals 1, x plus 2 squared equals 1. Or x plus 2 equals negative 1, because, again, if x plus 2 is negative 1, then we have negative 1 squared, and that's 1. So x equals negative 1, or x equals negative 3, and there are our solutions. Now, completing the square is actually the way you derive the quadratic formula. And I'm going to do that kind of quickly in the next video, just so you have pretty much a complete understanding of quadratic equations at a pretty high level.